So the question is the second one in problem set 5, which is the thief and the policeman problem. So originally it was the Ant-Man problem, but I figured out that not many people watch the movie Ant-Man, so I changed it to something that's understandable. So the way I write this is I write the first payoff as the police payoff. So the first numbers, these are the police payoff. And the second number, these numbers are the thief or the Ant-Man's payoff. In the earlier version I posted, these two numbers are switched, that's wrong, so now it's fixed. When we want to write down this indifference condition, so the first choice when doing these kind of problems is always write down the indifference condition instead of doing the best response. So the indifference condition is given by payoff from G is payoff from N for both players. So let's do it for the police first. So payoff from G, so let's assume the thief does the alpha 1 minus alpha thing again. So the thief plays G was probably alpha and N was probably 1 minus alpha. Then the police, when I go, then I will catch the thief with probability alpha, which then I get the fine minus the cost and multiply by this probability. If I didn't catch him, then I just get the cost of going, which is probability 1 minus alpha. So this is the payoff from G, and the payoff from N is always 0, so I don't even need to multiply anything. So then from this I can compute the alpha, right? So the alpha is these two would cancel out to, not cancel out, will just become 0.03, and this is alpha times U, so alpha is any 0.03 over any U bar. And then let's move this to somewhere where you can still see the payoff matrix. So then let's do it for the other guy. So still is the payoff from G is equal to the payoff from N. So my writing is becoming not understandable. But anyways, it's the same thing. So the payoff from G equal to payoff from N, so let's assume it's beta 1 minus beta for mixing for the police. So let's calculate the payoff for Ant-Man, the thief. So if I go, I choose this, I get the fine if I meet the policeman, so I get minus U bar with probability alpha, and I get 1, I get to steal the money if I don't meet the police, and it's equal to if I don't go, I always get 0 again. So it should be similar. So what's this? So it's 1 minus alpha is equal to, so let's not do it this way. So 1 minus 1 plus U bar times alpha is 0. So these are equal to each other. So alpha is equal to 1 over 1 plus U bar. So we have these two. Yes, I used alpha instead of beta, that's right. So this is beta, this is beta, and this is beta. So now we have a pair of mixing. So alpha is the thief's mixing probability, so this and 1 minus this is the strategy of the thief, and then this and 1 minus this is the strategy of the police. So this is the mixed strategy natural equilibrium. That's what you need to write. If you want to substitute U being equal to 2, 4, and 6, it's okay. If you leave it like this, it's more okay, because then you can know that when U is increasing, the probability of going for both of them is decreasing. So I think that's all I want to say.